Welcome to Conversion Stoichiometry. So, many calculations in chemistry involve stoichiometry. In stoichiometry, you are given an amount of one substance and want to know how much of a different substance will react or be produced. So by amounts here we may mean grams or moles or liters of a gas. So some measurement of how much we have. So to solve these types of problems, we need to do a few things. We need to convert the units of the supplied data to moles. We need to use the ratio supplied by the coefficients of the balanced equation to convert from the given moles to the wanted moles. And then we need to convert to other wanted units if necessary. Now, there are many types of stoichiometric calculations, but for now, we're only going to look at reactions that go to completion, which means until at least one reactant is used up. To start with, we're going to look at cases in which single amount is given and is completely used up. To solve these types of problems, there are 7 steps. First, we write wanted equals question mark, and then the unit and substance formula that are wanted. Second, we list the data, including the prompts that we've learned previously. Third, we balance the equation. Fourth, we use that equation to form our bridge. So we write the mol-to-mol ratio between the wanted and given formulas, using the coefficients in our balanced equation. Next, in order to solve, first we write the wanted unit and substance, and then equals the number and unit of our given substance, and then we convert to moles of our given substance. Then we convert to moles of our wanted substance using our bridge mol-to-mol ratio, and then we convert from moles of our wanted substance to whatever other unit we have in our wanted. So let's look at an example. Sodium burns to form sodium oxide. How many grams of sodium oxide can be produced from 2.30 grams of sodium? And then the unbalanced equation is given to us. So the first step is to write the wanted. So wanted equals question mark unit and substance formula. So wanted equals question mark grams, because we want to know how many grams of sodium oxide. And then sodium oxide has the formula Na2O. Next, we're going to list our data, including the prompts that we've learned previously. So we've got our wanted. Now we have the data. We were given 2.30 grams of sodium, and this is the only single unit in our data, and so this is going to be used as our given. Now we know from the grams prompt that 1 mole of sodium equals 23.0 grams of sodium. We also know from the grams prompt that 1 mole of sodium oxide is 62.0 grams of sodium oxide. Next, we want to balance the equation. So we've got our wanted and data sections. Now we have our unbalanced equation down here. Now we have 2 sodium atoms on the right side. If we plug a 1 in there, that means we need 2 sodium atoms on this side. But now we have 2 oxygen atoms on this side. We only have 1 over here. So we need to change that 1 to a 2, so that we have 2 oxygen atoms over here. Then we can say 1 there. But now we have 4 sodium atoms over here. So we need to change this to a 4. And now we have 4 sodium atoms on the left, 4 sodium atoms on the right, 2 oxygen atoms on the left, and 2 oxygen atoms on the right. So now we have a balanced chemical equation. So the next step is to write our bridge. So we write the mol-to-mol ratio between our wanted and given formulas using the coefficients of the balanced equation. So now we have our wanted and data sections, including now our balanced equation. So down here we're taking the given substance of sodium, and we know that we have a mole ratio of 4 moles of sodium to 2 moles of sodium oxide. And note that here this is the moles of wanted to moles of our given. So next we're going to do our solve step. So first we're going to write our wanted unit and substance. So we have the grams of sodium oxide, and we're basically just copying that down from above. And then equals the number and unit of our given substance, so 2.30 grams of sodium. And then we're going to convert to moles of our given substance. So we're converting from grams of sodium to moles of sodium. So grams of sodium cancels there. and that gives us moles of sodium. So again, this conversion factor is coming from this line where we use the grams prompt to give us that equality. Next, we're going to convert from moles of our given to moles of our wanted substance using our bridge mol-to-mol ratio. So remember that our bridge mol-to-mol ratio is given here, 4 moles of sodium to 2 moles of sodium oxide. And that means that now we can plug on this second conversion factor and have 2 moles of sodium oxide for 4 moles of sodium. And that means that here we had our grams of sodium were canceling. Now our moles of sodium are canceling, and we're left with moles of sodium oxide. And last, we want to convert to the unit that we want. So we've already canceled out grams of sodium, we've canceled out moles of sodium, and gotten moles of sodium oxide. Now we're canceling moles of sodium oxide as we convert to grams of sodium oxide, and that then gives us an answer of 3.10 grams of sodium oxide. So when you're solving problems involving reactions, we always want to write the number, the unit, and the substance formula for every term in your wanted data and solve sections. Now yes, this is going to take some time, but we're going to do this in order to avoid errors in our unit cancellation. For example, in this calculation that we have here, we cannot cancel the grams of sodium with grams of sodium oxide, because those units are not the same. This is grams of sodium, that is grams of sodium oxide. That isn't the same unit. Even though we have grams in both of them, and we have sodium in both of them, it's not the same substance, and that means that those units can't cancel. But if we hadn't written our substance formulas here, then we'd have a calculation that looked something like this. And then we'd be really tempted to cancel those units. And now, our answer over here would be unitless, whereas up here, our answer is a ratio between mass of sodium oxide and mass of sodium. Here we have a unitless number that doesn't tell us as much, and this calculation then would give us a unitless number, which is not really what we have. We really have this ratio between masses. So units that measure one substance cannot cancel with the same units measuring a different substance. So look at how confusing our calculation becomes if we neglect writing our substance formulas. We have wanted equals some number of grams. We have a given of some number of grams. We have 1 mole is 23.0 grams. We have 1 mole is 62.0 grams. Then we have 4 moles equals 2 moles. And then we have question mark grams equals 2.30 grams times 1 mole over 23.0 grams times 2 moles over 4 moles times 62.0 grams over 1 mole, and that gives us some mass, 3.10 grams. And why do we not just say 2.30 grams? Because that one is in grams. Right? And so this calculation doesn't seem to make much sense unless you're able to go back and plug in the substance formulas back into each place where they should have been written in the first place. So be really careful as you're doing your problems. Yes, it takes more work to write out a little bit more when you're plugging in the substance formulas here after your unit, like grams, but it will end up saving you a lot of time in the end by not having cases like this where you don't really know what it is that you're doing. Because if you've got your substance formulas in there, you're more likely to be able to keep track of what it is that you've done already and where it is you need to go. Likewise, if you have a calculation like this, it makes it very difficult for your instructor to find out where you've made an error if you've made one. And so if you get an answer over here that is not the correct answer, and you've got a calculation that looks like this, it becomes very difficult to troubleshoot where that error is. It's very difficult for you, and it's very difficult for your instructor. So do yourself a favor, keep those substance formulas in there. You'll make fewer mistakes, and when you do make mistakes, your instructor is better able to provide help for you to solving and fixing those errors. So make the flashcards that are listed on page 181 of the textbook, and then run them until you can do them all perfectly. And that was conversion stoichiometry.